Someone on the mic?
Can.
Okay. So today we will do binomial distributions. Okay, and then also tomorrow. Okay. Then normal distribution will wait until after school holiday we come back. Okay. Then we will do normal distributions. Okay. So this is today index. Today is 27. Okay, let's go through this. Okay, so binomial distribution is a type of a discrete, okay, random variable. Okay, so you see here.
Teacher,
Yep.
can you see?
Why? Oh, Uzaina want to ask questions. Is it you all want to mention this? Can repeat example 5. Who's this? Oh, okay. Example 5. Okay. So as I start lah. Example 5. Okay, wait lah. Okay, look at example 5. Okay, 70% achieve a grade A for science subject. Okay, 2 pupils are chosen at random from the class. X represents the number of people who did not get grade A. Did not get. Okay. So get or did not get. Okay. So if you draw out the 3 diagram, okay, this one get grade A, this one will not get grade A. They choose 2 people, so this is the first student and this is the second student. So same thing, A and not A, and not A. Okay, so the percentage to get A is 70%, so the probability is 0.7. Okay, then this one will be 0.3. Okay, X represent what? This is very important. Always see X now is represent people who did not get grade A. Okay, so same thing. Because only 2 pupils, so the most is 2 only. So, but it can be from 0 and then 1, okay, and then 2. Okay, construct a table to show all the possible value of X with their corresponding probability. Okay, so you need a table, okay, and then the graph. Okay. So I think mostly you will make mistake is this one, no? Instead of getting grade A, you didn't notice this one. Actually, they want not getting grade A, no? Okay. If 0 means nobody did not get grade A, what's the meaning? Means all were getting grade A, no? So you see terbalik the other way around. Okay. So for X equal to 0, okay, so you see for nobody did not get grade A. Wow, very confusing, okay. Nobody did not get grade A. Means what? A1 get grade A, no? Okay, so AA, no? Okay, so this is AA is for the X equal to 0, no? Okay, or the R equal to 0, no? Okay, so 0.7 times 0.7. Okay, so this is why you get this. Sirania, is it what you want to ask? Is it what you don't understand about this part?
Yes, yes, teacher.
So do I need still to continue? The rest the same actually. You just terbalik because the X is the did not get grade A. Okay,
Okay,
right?
teacher. Clear now.
Okay, so now I answer Rosanna questions. Okay, 5.4 question 1, 5.4 question 1. Okay, so this one. Okay, 6 out of 10 pupils randomly selected have attended a leadership camp. Okay, so X is what? Okay, if 5 people are selected randomly from the group of pupils, X represent the number of people who have attend. Who have attend. Okay, this one have attend. Okay, who have attend. Okay, number of pupil. Okay, so because 5 people are selected, so the most you can go is until 5. Okay, means all attend. Okay, so it can be nobody attend 1, 2, 3, and 4 until 5. Okay, draw a graph to represent the probability distribution of the X. Okay, so first of all, you need to draw out. This one also is quite simple, attend and not attend. Okay, so 6 out of 10. So this is 6 over 10. Okay, for attending. Okay, so attending I put A. Okay, then not attend one I put A prime. Okay, so it's like this. Okay, A and then A prime. Okay, so this is for first people. Okay, so this is 6 over 10, which is 3 over 5. Therefore, not attending is 2 over 5. Okay, but I don't want to draw so many because the second people, third people, fourth people, and then fifth people raw. Then my tree diagram will be very, very few. Okay, so I'm not going to draw it. Okay, but the idea you must get it. Okay, so very simple for this because you have a learn it you have gone through the few example. Okay, you will know actually how you can write it. Okay, so example for P x equal to 0. Okay, this one means what? This one is the first people also didn't attend, second also didn't attend, nobody attend what? Nobody attend. Okay, so first people didn't attend, second people also didn't attend, until the fifth people also didn't attend. Okay, if follow these 3 diagram, it will be something like this: not attending, not attending. Okay, all the five people also not attending. Okay, so the first one of not attending, the probability is 2 over 5. Okay, the rest also the same thing. So times 2 over 5, 5 times. Okay, if you want, you can just shortcut, write in this way, 5 times. Okay, so this is the answer. Wow, very big, huh? 2 over 5 power 5. Okay, so it's 32 over 3125. Okay, so this one you want to write in the decimal, it will be 0.0124. Okay, so this is for probability for the x equal to 0. So then you do for 1, 2, 3, 4, 5. You have to do for each of this. Okay, I do for one more for you. Okay, how about x equals to 1? Okay, x equals to 1. We consider a first case. Then after that, we times times 5. Okay, so the first case is what? Only one. How to say? Only one attend. Okay, so for one attend, the rest not attending. Okay, then you remember 1, 2, 3, 4, 5. You times 5. Okay, so 5 times. Okay, 1A is what? The first one, A, is 3/5, the probability. Okay, then the rest is 2/5. Okay, power 4, because 4 times 1, 2, 3, 4. Okay, why 5 times? Is because it can be the first people attending. It can, after that it can be the second people attending, then the rest not attending, then the third people attending, then the rest not attending, then the fourth people attending, then the rest not attending, then the last people attending, then all not attending. So altogether is a 5 possibility there. So times 5. Okay, then you get the answer. Okay, then the rest you do the same thing. Then after that, use all this number, all these number are in decimal. Okay, plot the graph. Okay, Rosanna, which part you want to ask more? Okay, and repeat example 5. Okay. 哎呦 battery low, wait for a while. 你到拿 battery 来。Okay, then we continue today's lesson. Okay. Okay, we want to see actually the previously what you have learned is very close to this binomial distribution. It's almost the same. Okay, like example that questions just now the 5.4 question 1. Okay, you see I label A and A prime. So attending or not attending. So it's only two possibility. Like the previous example, just now the Sirania asked one, the example 5, the same thing. Okay, get grade A or did not get grade A. So only two types of possibility. Okay, so here these two types of possibility here we simplify it, we call it success, okay, or failure. Okay, failure or success. Okay. Okay, so we consider this case. When a fair coin is tossed once, the outcome is either a head or a tail. Okay, not that the first situation have only two possible outcomes. That is either getting a head or getting a tail. If the outcome of getting a head is regarded as a success, so it's very important that you read the questions. Okay, what is considered a success? But sometimes throughout the questions you also don't know whether to assign the success as which one. Like example just now the getting A and did not get A. Actually just now you got to assign the did not get grade A as a success, you know. Even though we always say grade A is better, why grade A is become a failure. Okay, but here you know this is how you assign it. You have to read through the questions and then you got to pandai assign which one should be your success actually. Okay, then the outcome of getting a tail will be regarded as a failure. Okay, an experiment that produces only two possible outcomes is known as a Bernoulli trials. Okay, the characteristic of a Bernoulli trials as follow. Okay, so this one is just a name of it Okay, but seldom we use it At the end we'll still use this binomial But okay, the characteristic we go through still. Okay, there are only two possible outcomes. Okay, namely success or failures. Okay, the chance of success are always the same in every trial. Okay, this is very important. The second one, if the chance of success is different for every trial, then you cannot use this binary or the binomial distribution already. Okay, if the probability of success is given by P, then probability for failures is given by 1 minus P. Okay, this is very simple because the total probability is 1 ma. Okay, therefore only got two possibility. Is success, is not failures. So one is the probability is P, the other one will be 1 minus P. Okay, then only add up will become 1 ma, the total probability. Okay, so where P is in between 0 to 1. Okay, the discrete random variable X is equal to 0, 1. Okay, where 0 represent the failures and 1 represent the success. Okay, we come to see this. Okay, an experiment which is made up of n similar binary trial is known as a binomial experiment. Okay, now we want to see how we relate this binomial with binary trials. Okay, I will want to skip this activity. Okay. Okay, I will just write here. I create my own activity. My one is more simple. These are both activity like I see like got no meaning one. Okay, you toss a dice. Okay, and then okay, if you toss a dice, okay, if I dice you have a number 1 until 6 1, 2, 3, 4, 5, 6 if I set okay, getting even number okay, is a success. Okay, then the other one, getting odd number, will be a failure. Okay. This is same thing. So this one is a binary trial. It's because you only have 2 outcomes. Okay, and then the probability, the chances of success are always the same. Okay, so what is the probability for you to get success there? Okay, this is a even number, even number, even number. So it's 3 out of 6. So it's half log. Okay, and then probability for you to get failures. Okay, 1 minus half. The 1 minus P is also half log. Okay, and then I will do it 4 times. Okay. Before that, okay, I didn't say I did do it 4 times. This whole thing, we call it a binary trial. Okay, now I repeat, I do it 4 times. Okay, so this one now will become a binomial. When you have a repeating, okay? Okay, so now you see this. The experiment consists of 4 similar binary trials. Okay, each trial has only 2 outcomes, which are success or failures. Okay, the probability of success of each trial is unchanged. Okay, so it means you see, if the first time I tried, the probability for me to get success is half. Second time I tried, also the probability for me to get success is half. The third time, fourth time is still the same thing. This is the meaning of probability of success of each trial is unchanged. Okay, each trial is independent. That is, the earlier outcome does not affect the subsequent outcome. This is very important. Okay, so it means the first time I don't care is success or failures. The second time the result will not depend on the first time result. This is the meaning. Okay, each trial is independent. Okay. So this is in general. Okay, what is this binomial experiment? A binomial random variable is the number of success are from n similar binary trials in a binomial experiment. The probability distribution of a binomial random variable is known as binomial distributions. Okay, so you will still remember the x. Here, the x is the binomial. Okay, we will see on the example. Okay, for this example, maybe we see into this. Okay, if you do it 4 times, okay, so same thing, okay, for you to get an even number or the success, okay, the most is 4 times, okay, it can be 0 times, okay, 1, 2, 3, 4, okay, so x here is the binomial, Okay, same like the what you have learned previously, the probability distribution. This is a binomial distributions. Okay. Okay, we look at this example. Okay, tic-tac-toe. Okay, the diagram on the right show a tree diagram of all the possible outcome of after 2 rounds of a tic-tac-toe game. Okay, it is binomial distributions. Okay, you see, first round it can be win, it can be draw, it can be lost. Okay, second round the same thing. Okay, you have a three how to say, 3 outcome. Okay, 3 possibility outcome. Okay, so this is not binomial. Okay, the distribution has 3 possible outcome, namely win, draw, or loss. Therefore, this distribution is not a binomial distribution because a binomial distribution has only 2 possible outcomes. Okay, so this is very simple. Okay, here same thing they want you to know, make sure which type of distribution is a binomial, then which type is not binomial. Look at this example. This one also is not. Okay. Okay, you have a 6 chemistry book and 4 physics books. Okay, 3 books is taken. Okay, one after another. Okay, without replacement. This word, without replacement. Okay, make this question become not a binomial distribution. Okay, so that whether this probability distribution is a binomial or not. Okay, we will see why. Okay, because after you take the first, okay, let's say you take the first physics books. Okay, out of the 10 books, okay, since you have taken one and then you didn't replace it, so out of the 10 books, now left 9 books. Okay, so the probability for you to get a physics book again, okay, it will become a physics book 4, already taken 1, left 3. So you see the probability is different. Okay, so for if you want to you want this question to be a binomial distributions, okay, remember the probability for every try is must be the same. Okay, so you see the probability here is different. Therefore, this is not a binomial distribution. Okay, the probability of getting a copy of say physics reference book in each trial changes, and each outcome depends on the previous outcome. Okay, so the probability distribution of getting 3 copies of blah 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 without replacement is not a binomial distribution. Okay, if these questions are without this word, okay, they change it with replacement. Mean after you take the first book, then you put back. Okay, then you take one more time, then you repeat and for 3 times. Then this one is binomial distribution. Okay, so I think I hope you are clear. Okay, what is a binomial? Okay, so only got 2 possible outcome. Okay, success or failures. Okay, and then the probability for every trial must be the same. Okay, this is a 2 very important characteristic of a binomial distribution. Okay, so this one you do as homework. We see this. Okay, again you see this, your combination. Okay. Okay, so this one, copy this formula, very important. Okay, if a binomial random variable x represents the number of success in n independent trial in an experiment with p as a probability of success and q is equal to 1 minus p as a probability of failures, then the binomial probability function of x is given by the formula. Okay, so one more thing you need to know is q. Q is a 1 minus p, is the probability of the failures. Okay, so this is n trial. N trial. Okay, so n trial, the most you can go is until n. No? Okay, if like example you try 4 times, see, so the probability for you to get is until 4. Okay, I think it missed out one. No? One more here. You can have 0. Okay, 0 until 4 if you try 4 times. Okay. Textbook no other salah. Okay, then we also can write it as this. Okay, this is very important now. When the question they give in this way, you must understand what's the meaning. This one is tell that the variable x is a binomial. This B stand for binomial. Okay, and then with the okay, in the bracket, the first is the number of 12 and number of 12. Okay, and then P is the probability of success. Okay, so you got to understand the meaning of this. Okay, so this one you also have to copy. Okay, you see at the side here, these tips. Okay, I think your modern maths you have learned this mutually exclusive event. Okay, maybe I repeat a little bit here lah. Okay, the event of getting a success or a failure is an mutually exclusive event. Okay, what's the meaning of this mutually exclusive event is, okay, means the success and the failures will not happen together at the same time. Okay, it's either success, if not then failures. It's not possible the two happen at the same time. This one we call it mutually exclusive events. Okay. And now we look at this example. Okay, triangle pyramid with a 4 flat surface of equal size are labeled with a number from 1 to 4. Okay, it's like a dice. Okay, so dice we have a 1 to 6. This one got 4 faces only, 1 to 4. Okay, flip the triangular pyramid 3 times. Okay, so you do it 3 times. So here the n is 3. Okay, what is the probability for pyramid sitting on number 4 after each flip? Okay, sitting on number 4. Okay, so we let it sitting on number 4 be the success. Okay, so what is the P? Okay, sitting on number 4 is 1 face. Okay, out of all together is 4 faces, so 1 over 4. Okay, so what is the Q? Okay, the probability for failures, so 1 minus P. Okay, so it's 0.75 or 3 over 4. Okay, so you see n is 3. Okay, P is 1 over 4 also can, 0.25 also can. Q is 3 over 4. Okay, so X represents the random variable for the number of time that pyramid sit on the number 4. Then X, okay, because you do it 3 times, so the most it can happen is 3 times only. Okay, so it can be not happen at all, 1, 2, and 3. Okay, same thing. Actually, repeat the same thing only. Okay, so you see the outcome of pyramid sitting on number 4. This one actually is the success. So it labeled as G. Okay, and then not on number 4. So you see or not, only 2 outcomes. It's either sitting on number 4 or not sitting on number 4. Okay, we don't care if sit on the number 1, number 2, or number 3. We don't care. It's just sitting on number 4 or not sitting on number 4. So we consider this is as 2 outcomes. Okay, so here they label as G and a H. Okay, then they draw the tree diagram. Okay, tree crowd is still okay lah. Okay, so you label, okay, and then list out. Okay, GGG is stand for, okay, 3 times also getting the outcome as number 4. Okay, so 3 times. So here the X is 3. Okay, so this is 2G, 2G, 2G. Then this is 1G, 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 and then this is no G at all. Okay, so altogether 1, 2, 3, 4, 4 types of outcome. Okay, so next you find the probability. Okay, so when X is 0 means it's HH, when X is 3 means GGG. Okay, then the GGG, same thing lor, huh? Okay, we go back to the tree diagram. If GGG means 0.25 times 0.25 times 0.25 lor. Okay, and then if GGH2G means 0.25, 0.25 and 0.75. Got how many? 1, 2, 3, then times 3. See? 0.25 times 0.25 times 0.75 times 3. Okay, now you see this and this. Okay, this is how we drag in the combination. Okay, means out of the 3, 2 are success. Okay, out of the 3, 2 are success. Okay, so this is why you get this one times 3 replaced by with the combination 3 choose 2. Okay, you can press calculator. 3C2 is 3. Let us try. 3C2, okay, is 3. Okay, same as this. 3C1 is 3. Okay, out of 3, 1 success. Okay, out of the 3, no success. Out of the 3, all 3 success. This one we follow formula. Okay, why then you will say, teacher, why we use tree diagram lah? Why we want to use the formula? Some more have to, ayo, this formula like so complicated. You know the tree diagram like just now, you asked me to draw out the 5 level, I sudah talalat liao lo. Okay, so you need this. Okay, because sometimes the n can go to 10, 15, mampoi lo. Okay, then they will not ask you to list out all already. They will ask question and then you just need to list out certain. Okay, so this is why you need that formula. Okay, so I hope you know how to apply the formula. Okay, let us see this. Okay, what type of question mostly they will ask? Okay, note that the two methods, namely using tree diagram or using the binomial distribution formula, okay, will have the same property value for each of the value of the binomial distribution random variable x. Okay, however, the tree diagram will be difficult to draw once the number of ribs exceed 3. Okay, the probability of a pyramid sitting on the number 4 less than 2 times. This type of question, exam always they will ask. This type of questions, exam always they will ask. Okay, the probability of the pyramid sitting on number 4 less than 2 times. The x is smaller than 2, less than 2 times. Okay, so less than 2 times, it can be 0, it can be 1. It cannot be 2, because it says less than. Okay, so you just see this. Okay, you use a formula. Okay, and then do this, and then do this, and then add out. Okay, and then this is the answer. Okay, so you don't have to do the table. No need to do all. Okay, unless they ask you to draw the table and then draw the graph, and then you have to do all. Okay, if they ask you to draw the graph, no, don't worry, they will not give you so many one. They will give you like 3 trials is very big already, or 4 trials. Okay. Okay. Next, the probability of a pyramid sitting on number 4 more than 0 times. More than 0 times. So x is greater than 0. Okay. When x is greater than 0, it can take 1, 2, 3. Okay. So all together, you notice or not? Actually, if you add up everything, you still remember or not? You add up all this, you will get 1. Okay, so if the question they want this, this, and this, if the table is not done, so you want to use a formula to get these 3. You want to calculate this, and calculate this, calculate this. Got another way of doing. You just use 1 minus this. You just need to calculate this. Okay, 1 minus. Okay, the property for x equals to 0. Okay, it's easier. It's because you need to calculate only one property. Okay, compared to this, you need to calculate 1, 2, 3 probability and add up. But don't worry, the answer is still the same. Okay, so from the table above, okay, the total probability is this. Okay, this one we know already. Okay, this one also we know already. If this one you want to see the proof, why this the total probability is equal to 1, you can certainly think of. Okay. I don't want to go through you. Okay. How about this? What is the probability of a pyramid sitting on number 4? Less than once or more than twice. What is the meaning? Okay. So this one, what you have to do? X is what? Less than 1. Less than 1. X is smaller than 1. Or, okay, more than twice. X is bigger than 2. Okay, so what's the meaning? Okay, when you have or is plus. Okay, so smaller than 1. Smaller than 1 is 0 and 1. Is it 1 smaller than 1? No, sorry. Okay, it's only 0. Okay, 1 is not smaller than 1. Okay, 1 is 1. Okay. So for x smaller than 1 is only for x equals 0. Okay, for x greater than 2, we don't start at 2. Okay, so it's only 3. Okay. Then you find, okay, just add up. Okay, then the answer. Yeah, so exam, the question will ask this way. If they don't ask you to build the table and then get the graph, okay, then they will ask the question in this way. This type of questions, okay, or this type of questions, or this type of questions. Okay, 8. Okay, the probability that it rains on a certain day is a 0.45. Okay, by using the formula, find the probability that in a particular weeks it rains exactly 4 weeks. So you see, it rains. Okay, so make the rains be success. Okay. So the probability for it rains is 0.45. So this is the P. Probability for success 0.45. Okay, so the Q is 1 minus 0.45. So you get 0.55. Okay, get ready all these informations. Okay, then what is N? Because they're asking in a particular week. So 1 week is 7 days. Okay, so N is 7. Okay, then they want to find the probability it rains exactly 4 days. So means they're asking for probability x equals to 4. Okay. So all this information you write out. Okay, I think no problem. Just put in inside the formula. Why? Sonia, off your mic. Why? She be saying, ayo, what's happened? Here. Okay, let us see the formula. Okay, I copy here the formula. NCR PRQ N minus R. Okay, this is the formula. Okay, so if now you compare and see the R is 4. Okay, so the N is 7. So 7C4. Okay, and then P to power R. So P is 0.45. So 0.45 power 4. Okay, and then Q is 0.55 power 3. How you get 3? 7 minus 4, you get 3. Okay, just remember this 4, the power 4 here and the power 3 here, you add up is the N. Okay, then just press calculator to get the answer. Okay, so B. Okay, find the probability. Okay, at least 2 days. Sekurang-kurangnya 2 hari. Okay, minimum 2 days. Okay, so 2 and onwards. You see or not? Got equal sign. 2 and onwards. Minimum 2 days. At least 2 days is minimum 2 days. So it's 2 and onwards. Okay, 2 and onwards is 2, 3, 4, 5, 6, and 7. Okay, why no 8? Because N is 7. So last is 7. Okay, I don't want to use the formula to find this, so many row. I want to use the 1 minus. Okay, so all together is 0, 1, 2 until 7. Okay, so 1 minus, okay, probability for x equal to 0 and x equal to 1. For this, I only need 1, 2. I only need to find 2. Compared to this, I need to find 1, 2, 3, 4, 5, 6. Okay, so rather to choose this way. Okay, so same thing. Okay, px equal to 0. Okay, so this is the formula. Px equal to 1. This is the formula. Okay, press calculator, then you will get the answer. Okay, there. You can see this. What's the meaning of NCR? Okay, means that there are all success in n trial. Just like I said already, no? Based on the example 8A, in 7 days, any 4 days are chosen. Okay, so choose 4 out of 7. Okay, 4 times the probability of success, 3 times the probability of failures. So actually, you don't have to memorize this formula. Okay, it's quite simple. Okay. Are you still there? Someone on the mic? Or I'm out already? I'm very scared of like that thing.
Yes.
Yes. Okay, then we continue a little bit more. Actually, because I go fast is because this one actually is same like the what you have learned in the previous lesson. It's quite similar. Okay. See this one again the same thing. Construct the table, draw the graph. Okay. Let us see this example. Okay, you have 4 red balls and then 6 blue balls in the container. Okay, choose a ball. Record the colors. Okay, repeat 5 times. Okay, so here the n is 5. No? Okay, but what is a success? Okay, here they say suppose x is a random variable of choosing a blue ball. Okay, so this one they let the choosing a blue ball be the success. Okay, then they ask you to construct the table. We don't do lah. Okay, so they repeat the same thing. You see. Okay, here I just want to bring up this. Okay, so this is the graph. Okay, you know how to draw already. Okay, if any n of a binomial distribution, when the p is 0.5, the graph is symmetrical. Okay, symmetrical means something like this. Okay, mean this side and this side same top. Okay, then followed by this side and then this side. Okay, same the top. I mean the height. Okay, this is for the first case. Okay, then for the second case, if the p is smaller than 0.5, the graph is skewed to the left and is not symmetrical. Okay, let's see this. What is a p? Using a blue ball. Blue is 6 altogether. Okay, the whole container having 10 balls. Okay, so 6 out of 10. Okay, so it's 0.6. 0.6. Okay, so this one is at the third case. Okay, p is greater than 0.5. Okay, just now the p is 0.6. Okay, so when p is greater than 0.5, okay, you screw to the right. Means you see or not, the right hand side one is taller than the left hand side one. This is the meaning of a screw to the right. Okay, if you join, how to say if you join, you can see is the right hand side is a segment. Okay, to one side like that. Okay, so these 3 you have to know. Okay, if the question asks you, okay, or the graph after you draw already, you can see whether it's correct or not. Okay, if not correct means something wrong somewhere, huh? Okay. Next. We look at this example. Okay, use school buses to come to school. 45% use school buses. 45%. This one will give you the probability. A sample of 4 people is randomly selected from the school. So this is the N. Okay, construct a binomial probability distribution table for the number of people who use the school buses. Okay, so for use school buses, this is success. Use school buses, this is success. So the probability for success is 45%, which is 0.45. Okay, 45 over 100. Okay. Then, because you have 4 pupils, so the most you can go is 4. Okay, so start from 0, 1, 2, 3, 4. Okay, so N is 4, P is 0.45, get the Q 0.55. Okay, build the table from the 0 until 4, from here, 0 until 4. Okay, then use a formula, get the probability for each. Okay, this is the table. 2. Draw a graph for this distribution. Okay, then from here you draw the graph. Okay, now we want to see the P. Okay, P is 0.45, smaller than 0.5. Okay, it says it's screwed to the left. Can see or not? The left one is higher than the right. The left one is higher than the right. Okay, so most probably the whole answer is correct. Okay, then we want to answer the questions. Okay, from the table or the graph, find the probability that more than 3 people come to school by bus. More than 3. X is greater than 3. X is greater than 3. X equal to 3 cannot take. Okay, X equals to 4 only. Okay, so from the table, this is the answer. Okay, less than 2 pupils use a school bus. Less than 2. X is smaller than 2. X is smaller than 2. 2 cannot take. Okay, so you have 0 and 1. Okay, 0 and 1, take these 2, add up, then this is your answer. Go to example 10. Then that's all for today. Okay, the diagram on the right show a binomial distribution graph. The balik, now they give you graph. Okay, you have to answer the questions. State all the possible outcome of X. Okay, so the possible outcome for X is 0 until 4. So list out 0, 1, 2, 3, 4. Okay, find the value of N. Okay, how to find the value of N? Okay, you must know this. Past year, recent year, a few years already got these questions. Okay, so probability for X equal to 0 until probability for X equal to 4. Okay, the total is 1. Okay, so for probability for X equal to 0 is 1 over 16. Okay, probability for X equal to 1 is N. Probability for X equal to 2 is 5 over 6. Okay, probability for X equal to 3 is N again. And then probability for X equal to 4 is half N. Okay, so we read, okay, and then get the value, okay, and then add out, let it equals to 1, and then do for N. Okay, solve the linear equations. Okay, then you get the N. Okay, that's all. Then do this exercise. How many exercises today? 5.5, 5.6, and 5.7. 3 exercises. That's all. If cannot finish, then never mind lah. But tomorrow I will finish this subtopic. Okay, then your holiday you do slowly lah. Okay. Then if tomorrow start some part want to ask me question during holiday, also you can WhatsApp me and ask me question one. Don't worry. No tension. Okay. Any questions before I end my lesson?